So let's turn our attention over to Excel's financial functions. You'll find that most of the financial functions, they tend to use the same structure, the same syntax, and the same number of arguments. So for example, if I were to, let's say I click in here, put in present value, tab ones. So you can see the arguments, what it's asking for. It's looking for rate, and rate refers to the interest rate for the period. It's looking for the NPER, which in fact is the number of payments. In addition to that, it's looking for the payment amount. So let me just take this out and we can run through an example. But just to clarify the concept. So the present value, or the PV, represents the total value of a transaction in today's dollar. You want to know what this thing is worth today. So if you were to purchase an insurance policy, let's say the policy plans to pay you $10,000 in 20 years, you can use the PV, or present value function, to figure out if the payments you are making now, the monthly payments you're making right now on that insurance policy, to see if it is worth the investment. So if I were paying $100 on it, and let's say the total amount that I paid came up to like 5,000, and it's going to pay me 10,000, well, definitely it's worth it. I'll end up making, double my money. So the PV can help you figure out what the value of that policy is worth today. On the other hand, the future value function uses the concept of the future value of the series of payments over the period of, let's say, 20 years, using the same insurance policy concept. You want to know what this payment you're making now on a monthly basis or a yearly basis will be worth in 20 years. Okay. And the net present value, or NPV function, it calculates the net present value of an investment. So your initial investment here is 10,000, and you have a discount rate of 10%. And you have these yearly returns, these series of payments, and you want to know what the net present value will be of this $10,000. Okay, so let's look at it in terms of an example using these numbers. So I'll start by calculating the present value. I'll click in C9. I'll go to the Formulas tab, select Financial, and scroll down, select PV for present value. So what is the rate? Well, the rate here is 7%. Okay. Now, because the payments are done on a monthly basis, I need to divide this 7% by 12 to get the monthly rate. So the total number of payments per period in here will be C6, which is 10. And I need to multiply that by 12 in order to calculate the, because this is based on it's yearly. So I need to calculate the total 12 months by the number of years, which is 120. Okay, and then the payment amount is 2,000. And because I'm not looking for the future value, I can skip that. And let's click in here. I'm looking for, I'll put in 1 because the payment starts at the beginning of the month. Hit OK. And this tells me the present value of this payment, monthly annuity payment over a period of 10 years. The present value is worth $173,000. Okay. So let's calculate the future value using the same arguments or the same logic. Again, I'll go into Financial. I'll select FV for future value. What is my rate? My rate is 4.5%. And this is once a year. Okay. And what is my net? The total number of payments. Total number of payments in this case represents, this is F5, 15. Okay. The and the payment amount. So what is my payment amount? In here, my payment amount is represented by F5. Okay, are you following along? Okay. And of course, you put this as a negative amount because you are paying out. This is how much you're actually paying out on a yearly basis. Okay, so you can skip the future value box. You really don't need it. And in the type box, you can just leave this empty as well. So when you select OK, this is the future value, yearly deposit of $2,000 that you're paying out over 15 years at a rate of 4.5%. Tells you the future value. So you can know if you're trying to put away, let's say $40,000, this tells you this is the minimum you need to deposit on a yearly basis over 15 years at this rate to end up with about 40,000, 41,000 in your IRA account. Okay. All right. So let's look at the NPV, or the net present value calculation. All right. So select C19, and again go back to financial, and I'm just going to scroll down. Of course, there are other ways you can find the function. Another way, click the function, insert function, and then you can scroll down over here to NPV, or you can do a quick search. I'm going to select OK. So what is my rate? Well, my rate in fact is 10%, which is C13. And what is the first value? The first value is C16, and I'm going to show a series of payments. So it'll be C17 and another payment, C18. Okay, and we can just select OK. So now this is telling us that the net present value of 12,000, but this is not entirely correct because out of this 12,000, we initially invested 10,000. So we need to factor this back in to see what the true net present value is. So to do that, you can just simply correct your formula. You can select F2, put a plus, and add your initial investment, and you can see the net present value is 2,144. Okay, so that covers Excel's financial functions.